The James Webb Space Telescope, additionally known as Webb or JWST, is a logical pioneer that has uncovered astonishing insights concerning stars, planets, cosmic systems, and other intriguing vast peculiarities, setting new guidelines for logical fervor. Webb is hailed as the respected Hubble Space Telescope substitution. People from all over the planet are trading photographs or utilizing crude information to make new bits of knowledge. 1 year has passed since the imposing James Webb Space Telescope divulged its very first memorable picture of the universe, stunning space experts overall with its phenomenal detail. Anyway, its latest finding is a frightening image of the universe that we have never seen before. What has been found so far by the James Webb Space Telescope is offering more conversation starters than answers for researchers. Join us as we investigate how the James Webb Space Telescope captures the most startling picture of all time. Found in history, the replacement to the Hubble telescope divulged new data about star arrangement, system consolidations, and the early universe only 1 month after the underlying photographs were delivered. The photos were amazing, uncovering the universe in dazzling detail. From that point forward, the quantity of disclosures has soared, providing researchers with a colossal data goldmine. James Webb Space Telescope observations of inestimable tarantulas, record-breaking space smoke, stars on the edge of cosmic explosion blasts, and other unbelievable heavenly items have been documented. This satellite observatory's cutting-edge innovation permits us to peer farther into space than before, revealing previously obscure insights regarding the universe. Another time in cosmology has unfolded because of the photographs, which can be so detailed. As a method for celebrating the first year of the James Webb Space Telescope's activity, NASA delivered a picture that shows a little star-forming region in the Column-Ocky cloud complex. The picture shows planes emitting from new infant stars as inestimable residue billows of different tones impact atomic hydrogen, which makes up the red residue. The presence of a circumstellar plate projects a shadow on a couple of stars, suggesting the probability of planet formation in the far-off past. The image might show astronomical anarchy, however, as per NASA, this heavenly nursery is minuscule and quiet compared to others. Also, many of the youthful stars in this space are about the size of our Sun or considerably more modest, making it the closest star-forming district to Earth. This image was caught by the fundamental camera of the observatory, the Webb Space Telescope's close-to infrared camera, which captures enormous pictures in 2 unmistakable infrared ranges at the same time. Moreover, the Space Telescope has worked on our information on exoplanets or worlds that circle stars other than our Sun. James Webb is especially great at checking huge-out universes. The satellite observatory found its first exoplanet, LHS 475b, toward the start of 2023. The planet is 41 light-years far off and has a breadth equivalent to Earth. According to NASA, James Webb is the sole functional telescope able to do ordering the environment of Earth-sized exoplanets. After that, the James Webb Telescope found evidence of long-on systems that, from a hypothetical viewpoint, shouldn't have existed. Eva Swindon College and her Around the World Cosmic Group have seen 6 colossal old cosmic systems called refrain breakers. They can potentially completely impact the manner in which we ponder space. These huge systems might have appeared between 500 to 700 million years after the Big Bang. According to the specialists' results, recently the telescope's infrared sensors identified them through the utilization of these instruments, permitting us to look back in time around 13.5 billion years when stars and systems were a lot younger. The colossal mass of the universe breakers has left researchers baffled. Worlds in the early universe ought to have been 10 to 100 times less than that. Their computations show that these 6 items might be billions of times heavier than our Sun. The amount of the multitude of stars in one world may be 100 billion times heavier than our Sun. Does the possibility of attempting to figure out something so monstrous make you feel really uncomfortable? Despite the fact that most cosmic systems during this period are generally little and just extending marginally, a few beasts arrive at adulthood undeniably more rapidly than others. It is clear what would cause this or how it would capability. Penn State College cosmology and astronomy aide professor and study co-author Joel Lader expressed his bewilderment at the revelation of a new classification of items formed at the Big Bang. the discovery that the development of tremendous cosmic systems began at the very start of the universe's set of experiences challenges large numbers of our recently held convictions about the condition of science. It appears our revelation is so out of the ordinary that it presents difficulties to the academic community. It throws into question the whole situation of how systems formed in the early universe. Surprisingly gigantic describes the things. All cosmic systems in the range are viewed as infants since they are still during the time spent development. Anyway, systems that are essentially as old as our own have been tracked down in the early universe, which was recently remembered to be its starting spectrometry. What isolates light into its part frequencies to empower more precise distance estimations is as yet expected to approve the outcomes, which have researchers scratching their heads. There are just a modest bunch of as-of-late found objects for which distance and mass have been confirmed. If the information is precise, universe creation needed to have been significantly more effective and quick than what is currently suspected. The way that spectra certified our norm working frameworks-based deductions from the visuals is promising. For a really long time, researchers have tried to interpret astronomical history. By and by, a solitary piece of hardware may hold the critical perceptions of room and time that have long piqued the interest of researchers. So it isn't as business as usual that conflicting realities presented by telescopes could prompt an absence of clearness. As of now, cosmologist Dr. Katie MacBrings decided to the table for her bits of knowledge into the matter to make sense of how this could be happening. She pointed out the way that the JWST has been giving proof of worlds that appear to have started or evolved a lot sooner than what researchers had expected from their models. Don't stress, however, as Mac called attention to, the telescope is capturing pictures of universes more than 13 billion light-years away, and they are to some degree foggy. It seems like there hasn't even been sufficient time since the Big Bang for these large universes to have formed by the dates that cosmologists have been getting from the telescope. Numerous in the field that this projects make stress uncertainty on different hypotheses, including dim matter and the Big Bang. However, we ought to go further into the proof to find out without a doubt. The telescope catches amazing perspectives on close nebulae, yet fluffy little specks with regards to faraway systems. The explanation is that various varieties are impacted by various pieces of the light range. The Webb telescope can identify light from a source in two distinct ways. It might use a range by fanning out the light with a spectrograph, which works a bit like a prism, and looking at the brilliance of each tone, or it can utilize channels that block everything except a select scope of varieties. They can then ascertain the redshift of the system by looking at this information with spectra anticipated for systems with similar attributes. What this redshift illuminates us is the accurate moment in Big Bang history that we are seeing. Incidentally, numerous worlds have an abundance of stars or stars that were too youthful when they would have lived by examinations of model spectra. There are a number of potential clarifications for this. The photometric readings could have been off in light of issues with the telescope's adjustment, or they might have been noticing a group of universes that isn't representative of the standard or very little areas of the sky. Another conceivable clarification is that universe range models are planned for closer universes, which don't work well with cosmic systems further away. On the other hand, cosmologists would confront the exciting possibility of having to completely reevaluate astronomical advancement if those cosmic systems are to be sure very enormous and prior assessments were mistaken. However, it's not really the main region where researchers have missed the mark. Notwithstanding innovative advancement, planets that are quite enormous to exist have specialists exceptionally confused, and none more so than the finding of a planet that is considered as well monstrous for itself. This has provoked a reassessment of our system comprehension of planet creation and nearby planet group design, as well as the models created by cosmologists. In the fallout, a planet that is multiple times as immense as Earth has been viewed as, according to research out of Penn State. Legend has it that this planet is in a planetary framework around the ultracool star LHS 354, a star that is multiple times less enormous than our Sun. Before, as of late, seeing it for themselves, researchers didn't really accept that such a situation was doable. Yet new proof shows that the biggest planet in our planetary group is in reality circling one of the universe's littlest and coolest stars, a ultracool dwarf. We still have hardly any familiarity with the universe, and this finding demonstrates it. Considerably more, a planet of this mass circling a star with such low mass opposes our expectations. These stars might have started in huge gas and residue mists, and planets might emerge from the gas and dust that stays in the disk of material around the infant star. Later, it isn't guessed that the planet framing plate encompassing the low-mass star LHS 354 contains sufficient strong mass to deliver this planet. Anyway, it exists, so we should now re-examine our hypotheses with respect to heavenly and planetary development. A decent relationship would be to contrast the stars with an open-air fire. In request to keep up with your internal heat level, you should get closer to the fire as its temperature diminishes. Planets are no various. Planets that need to be hot enough to support fluid water should be nearer to stars with lower temperatures. In the event that a planet is in a sufficiently tight circle around an ultracool star, we can see the pull of the planet on the star's light or spectra, which causes a small change in the star's variety. Then again, turn upward high. Another stunning picture of the ice giant Uranus, highlighting almost all its dusty rings, which had recently been hard to photo, has been snapped by the James Webb Space Telescope. For the fainter rings, which have just been seen by the Voyager 2 and Keck Observatory on government rockets, the image is a stunning showing of the telescope's responsiveness. Uranus, which is 1.12 billion miles from the Sun, has 13 perceived rings, 11 of which are displayed in the stunning new picture from the Webb Space Telescope. As opposed to Saturn's even rings, this planet's impossible-to-miss side slant causes its rings to show up vertical. The two external rings were not distinguished until the 1986 flyby of the Voyager 2 space apparatus on the grounds that their dusty cosmetics made them not so much apparent but rather more hard to photo. The 9 significant rings were at that point known before then. In 2007, photographs caught by the NASA Hubble Space Telescope uncovered 2 more fainter external rings that are not apparent in the Webb photo. Webb can possibly catch them, according to researchers. A planet's ring framework gives important data with respect to the planet's beginning. Uranus is a very exceptional globe with its skewed circle and non-appearance of inside heat. In this way, any data with respect to its past would be exceptionally appreciated. The particular environmental cosmetics of the enormous gas-based planet Uranus is something that researchers are trusting the telescope can reveal insight into, since no other telescope of this scale has at any point been ready to see infrared light. The JWST permits us to inspect Neptune and Uranus through a sacred novel focal point. Telescopes that utilization apparent light, like Hubble, can't notice infrared frequencies. Yet infrared imaging can uncover already inconspicuous profundities and include remarkable film of a star approaching demise. This has been procured by the James Webb Space Telescope, with JWST late 2021 sending the blurring star picture. This is the first faultlessly recorded occasion of its sort. The tremendous biting the dust star Wolf-Rayet 14 was caught on film by the telescope's infrared focal point as it catapulted gas and residue into space. It is trusted that this divine occasion is happening 15,000 light-years from our planet. Not certain what it implies, however, it's around 58 trillion miles away. The image, which was given simply by NASA, shows the glistening purple remainder of the star's external layer, which was beforehand a slight cloak of residue and gas, making the star flare. This staggering picture is an enhancement for the one that the Hubble Space Telescope caught a couple of years prior. In 2015, before the JWST was sent off, the star on the move was recorded by the Hubble Space Telescope. It appeared to be more like a blasting ball, however, on the grounds that our innovation couldn't catch the better subtleties. Anyway, the demolition caused by Wolf-Rayet 14 is currently obviously apparent. The fact that the consumed star, which makes it trusted, is situated in the constellation Sagittarius, is multiple times greater than our Sun. In addition to it, it has removed an adequate number of gas and residue to cover 10 suns for now, at any rate, as per NASA. A star is in the focal point of this dazzling new picture. For the beyond 15,000 years, that star's light has been advancing across the universe. It will require 15,000 light-years for it to arrive at the telescope's finders. What seems, by all accounts, to be dust around the middle star is really dust. In light of the fact that when a star passes on, it delivers its external layers and material into space, as found in the outline. Planets will structure from this residue as it fans out into space. Really, this is how we've shown up right now. Specialists accept that a star during the time spent shedding material is going to detonate, a peculiarity frequently known as going cosmic explosion. Albeit the breakdown of Wolf-Rayet 14 will be imperceptible to the human eye, 5 planets will be apparent from Earth. Stunningly, a genuine beast in space had its appearance caught by the James Webb Telescope. The ghastly substance was seen by the JWST as it snuck in space. Really, it's a cosmic system that produces many new stars every year, not some gigantic extraterrestrial. The universe, which has the assignment Aztec C71, was at first found right around 10 quite a while back by a ground-based telescope. Anyway, when the more refined Hubble Space Telescope analyzed it, it vanished. With the assistance of the James Webb Space Telescope, the tragically missing cosmic system has now made a victorious return. The universe Aztec C71 appears as though it's shouting into the pit in a craftsman's portrayal, which gives the appearance that it has 2 eyes and a vast mouth. Its tracking down modifies how researchers view the early universe and raises the plausibility that colossal star nurseries were 3 to multiple times more normal than recently thought. According to the group's computations, the redshift of the universe being noticed is roughly 6, which places it at roughly 900 million years post-Big Bang. A genuine beast, this thing, the little mass is as a matter of fact liable for the introduction of many stars every year. Regardless of appearances going against the norm, what, truth be told, invigorates us is that our most current telescope produces pictures that are so delicate that even something so emotional is scarcely perceptible. An enormous number of worlds might be uncovering themselves to us in this manner since dust assimilates most of the starlight and transmits it at redder, longer frequencies. Dusty cosmic systems have demonstrated testing to photo before this. Our only method for noticing systems in the early universe had to deal with the optical focal point of the Hubble Space Telescope. Since our eyes are restricted to the unmistakable, residue-free worlds, our insight into cosmic system development is slanted. Anyway, the Hubble Space Telescope can't identify infrared qualities that the NASA James Webb Space Telescope can. Since JWST is sufficiently delicate to look into the universe's farthest corners and transparent indeed, even the thickest residue cloak, it will permit us to inspect the optical and infrared qualities of this up until recently concealed gathering of universes. In an effort to early investigate the universe's highlights, the Universe Web Project plans to map up to 1 million cosmic systems from an area of the sky the size of 3 full moons. Notwithstanding the observatory's notoriety for gazing into space at the farthest conceivable distance, NASA has moreover used its complex sensors to make discoveries in our own backyard. Utilizing the itemized photos of Mars that Webb required last year, researchers can analyze more transient peculiarities like dust storms, atmospheric conditions, and occasional moves. However, the red planet is a challenge for the strong space telescope since the infrared light from Mars is blinding the instruments on board due to the very brilliant circumstances. Stargazers needed to utilize specific information investigation strategies and very brief openings to compensate the specialists who made these discoveries. They guarantee they would break down the spectroscopic and imaging information to look for.